How's it going, everyone? Julian Gonzalez here. So today we're gonna talk about the RxGX, about the operators, and get a more hands-on, um, or get our hands dirty about doing and creating these observables and how can we deal is with the concurrency, especially a series of eventual values. Now, because in the couple last video, we just described is how do we get here as a way to create now this story around the asynchronicity. And now, finally, we're going to take a look at this exercise and actually to understand that and how can we use that to help us to cover the most common use case. So for example, how can we now is capture series of events from a bottom, for example, from or bind observables. So this is more like the Node.js or the server environment, and the no from fetch. In other words, like how can we detect that series of eventual values from the network, specifically from this URL. So when the server is streaming data, I would like to know and manipulate each one of those independent data that it comes through and pass through a series of steps so we can distribute that in our systems. So this is useful for anything that you need to space between now, or take at an nth value, or if the user is raging clicking on that interface, so let's want to wait until the users chill out a bit before hammering our API. Now, so here we are. We'll also look at the basic operators, the combining operators, take until, skip untils, some of the visualization from Rx Marbles, which is very, very beautiful and useful, and some examples of how can we implement that in a counter, right? How can we use this? I think I already did this. For close, basic operator, time intervals. This one, right? When it might be quite silly, right? But we implement that once, right? So we create now is this single observable here. So we also look at how can we create our observables. How can we create now is observables, basic observables with off and front, what is the subtle difference between them, and how to do that with from events, creating an observable from an event, and from timers. So for example, like this. So we create an interval, so we started subscribing and then we pause here. So anytime we started to detect is a series of events from this observable, we want is to do something about it. So for example, it's like, hey, what we're gonna call now is the interval subscription here. All right, so from this string of data, I wanna do this. I wanna emit this series of events. And when you click pause, it's just like this. So this is part of these basic operators here. And some of the common examples how you can create observables with from, okay, or with off, or with from. So creating observables is with single values or skip those values, using a filter to see what is doing behind the scenes, and also apply is the scan. But most of the time that's what you want because you want to apply now this reducer function or these functions to each independent elements or each independent events that come through. Now, let's get into finally of the manipulating time, right?
So now we're going to talk a little bit about manipulating time. So we've got another example in here called manipulating time. And this looks like the notifications that we had previously. Out of the box, it does exactly what we had before. Let's go and let's see some of the fun tools that we have at our disposal. We'll start out with a very simple operator. Let me go over to manipulating time. And you can kind of see some of the ones that we have to work with. I've already imported them here for us. We've got delay, debounce, and throttle. We've got some of our old friends, scan, map, and tap. But the ones we want to talk about, delay, debounce time, throttle time, debounce, and throttle. These are ways, as we talked about before, if someone starts rage clicking, maybe we don't want to slam the API, right? Maybe we want to ignore things. A common use case that we might use RxJS for is figuring out, okay, they're typing into an autocomplete, right? Every keystroke we want to send an API request to the search API. What about if when they're done typing for 300 milliseconds, then we'll go send one over. And so there's a bunch of, the ability to control the rate at which things happen is a set of super useful operators. So let's.
Yep. So now this is. Oh, okay. So manipulating time. So manipulating time. That's right. And this is manipulate time, emerging timelines. Manipulating time and the emerging timelines. Very, very, very powerful. Exactly. Manipulating time. So the ability to skip over or
and so there's a bunch of
or to
the
wait
ability to control
to
the rate at which things happen.
So the ability to control the rate at what things happen. Okay.
Is
super useful. It's incredibly useful, right? So manipulating time like this, manipulating time. The ability to control the rate at what things happen is incredibly useful.
Super useful operators. So let's take a look here and let's see what we can learn along the way. So we have this button and we want to delay it 2 seconds, 5 seconds, however many seconds you want into the future.
So you can create now an observable, pass an observable.
So we can pass in a delay operator and save that. And now I can go ahead.
Anytime we create a notification.
Mississippi to Mississippi, and it shows up. Right now, if I rage click, 1 Mississippi, 2 Mississippi, and here they are. Right? Because it's only delaying them 2 seconds from whenever they start. It's not spacing them out by 2 seconds. It's simple.
Exactly. So if we are using delay operator, we are just spacing out, for example, 2 seconds in this exercise. So let's take a look at this. Go to the code. Let's get into integration testing, fundamentals of front end. This is a Pokemon, intro v3, app, no, mock service, Rx fundamental. There you got it. He was showing
a little bit about manipulating time. Let's go and let's see some of the fun tools that we have at our disposal.
Yeah, but where we
have to work with. I've already.
This is on the loading state or manipulating time. So manipulating time here, there you got it. Okay, perfect. Awesome. So let's say here we can pass this now a delay operator of 2,000 seconds, of 2 seconds. So if we run this, that to me is quite interesting. How can I run this? It's going to, in fact, is do something like this. Say get log, get status thing, get switch to main, get pull everything from that remote repo branch. There you got it. So now we can create is a branch from this and say, hey, git switch of the manipulating or manipulating time, right? And here, let's going to now add this, right? This delay. So if we run this in our package JSON, then we say star, I think it is. Let's get into this npm star. Okay, is running that. You got it. All right, cool. So if we look at the manipulating time here, okay. So if we create this notification, that's what it's gonna do. So in other words, is this one is just a silly example of what we can do here. Okay, this silly example here. All right, and now with delayed, all right. Ooh, does it work? I'm working with the right?
Imported them here for bounce time to ignore things. They're typing into typing for is super however you want.
Oh,
so we can pass in delay operator and save that.
Makes
now,
a lot of sense. Of course, because it doesn't. This is not the property here. So what you can do is just to pipe this. You say, hey, let's go to pipe this because after all, this is an observable, and here's when you're gonna do this. So now, by the time you record this, so this is something that you might want to have, right?
And go ahead. 1 Mississippi, 2 Mississippi, and it shows up. Right now, if I rage click, 1 Mississippi, 2 Mississippi, and here they are, right? Because it's only delaying them 2 seconds from when they start. It's not spacing them out by 2 seconds. It's simply delaying them. And there's a whole bunch of really interesting ones. There are buffer, which will collect all of them in a certain amount of time and then give you an array of all the things that happened. There's a whole bunch of ones for, that probably aren't common enough to make it worth our time in a fundamentals course, but definitely, like at one point, you will have one use case where you need these, and they're there for you. But the common ones that we might have is, it'd be cool if we could stop the rage clicking, especially because once you add a delay to anything that's slow, I mean, I wrote this and I want to rage click it when it takes 2 seconds, right? And so what we could do is we could say throttle time 2 seconds. And I'll repeat this a few times because it bears repeating. Throttle time and debounce time are basically two sides of the same coin. Throttle time says let a thing
throttle
through
time,
and then ignore things because it bears repeating. Throttle time and debounce time are basically
Exactly. Throttle time and the bounce time are part of the same coin. Are basically two sides of the same coin. Throttle time and the bounce time. So we can do is this. All right. Now, throttle time, pipe delay. Okay. Git add everything. Git commit with a message from event. Just delay notification. Delay 2-second notification. All right. And then you say, hey, git push origin of this branch of manipulating time, because what I want to show here is this nice little here, right? So this show it was spacing out exactly. So this show how can we spacing out things for 2 seconds. However, most of the time we want is to wait for something before doing anything. Okay, so wait for it, wait for something before doing something. Okay, and that is, you go to the finder and then you pass this. This is a normal event emitted. In this show, how can we spacing out things for 2 seconds? For example, like this. How can we spacing out things for 2 seconds? Right? Okay. Woo, what the hell? Su madre. Stop! No, Jesus. Oh my God. Oh my. Hey, Jesus. Jesus fucking Christ. Oh my God, but why you are... My God. My bad. This is human error, bro. Human error. Chill, bro. It's not on this. It's on my own. Hey. It's on my own, bro. It's on my own, bro. It's on my own, bro. Jesus. Can we, please? God damn it. Okay. Mm-hmm. Mm-hmm. Human error, bro. Jesus fucking Christ. Anyway. Let's switch. Okay. And it's here, what I'm gonna do is that. So hell is going to now pipe this and pass now the delay of 2 seconds. Right? So far, so good. But what I do is on my own branch, bro. Git commit with a message. Okay. So add delay notification. And now, once we're going to create this branch here, this. I want to do that, but it's for my own repo, bro. Chill. Exactly. Come on. My God. And say is time manipulation. So add this to resource here. Like that. That's right. They're already hosting all of that services here. We're gonna compare it with our own. Exactly, because this is the PR2 again master. Okay, so create the PR but in our own branch. That makes sense. Okay. And then let's keep moving.
2 sides of the same coin. Throttle time says let a thing through and then ignore things for however long. Right? Debounce time.
Okay. And now we're going to explore is the concept of throttling. Throttling. I think it is throttling.
Throttle time says let a thing through and then ignore things.
Throttle time. So throttle time. Okay, throw and the bounce are two coins. Okay, throw and the bounce are two sides of the same coin. Throw says let's think through and ignore things and then ignore
things for however long. Throttle time and debounce time are basically 2 sides of the same coin. Throttle time says let a thing through.
Mm-hmm. Let this thing through. Exactly. Let this thing through.
And then ignore
things
for however long.
And then ignore things for however long. Okay. However long. So for example, it's like it's like in your shopping cart. Okay, letting thing through and then ignore, and then ignore or remove stuff for however long.
Right? The bounce time is going to be ignore everything until 2 seconds of quiet have happened.
Okay. And the bounce says ignore everything. Okay. So ignore everything until X amount of second has passed. So usually what you want to go with, especially for handling so usually what you want is, depending on the use case, is debounce or throttle. So throttle say, hey, let's let things pass through, okay? Let things pass through. Let things pass through, and then ignore for however long. Okay, so I'm gonna take this and then ignore for however long. 2 seconds, 3 seconds, whatever, you know. But let all of these things through and ignore for the next amount of time. And the bounce say no, don't ignore. Let everything pass. It's like no, don't let things pass through. Ignore them until the next amount of time has passed. So most of the time, what you want to do is debounce, especially if the user is raging, clicking on that button. Right? It's like no, wait until you chill a little bit, and then we can hammer our API.
I'm a parent. I relate to this. Until this time is going to be ignore everything until 2 seconds of quiet have happened. I'm a parent. I relate to this. Until there's 2 seconds of quiet, and then I will do whatever it is, the last thing that was queued up for me to do. Right? So throttle time is I'm busy. Wait a minute. The bounce time is I need a moment of peace. However many seconds of silence. Right? So throttle time is I'm busy. Wait a minute.
Okay. So throttle is I'm busy. Wait amount of time. Okay.
A minute.
I'm busy. Wait a minute. Okay. I'm busy. Wait a minute.
The bounce time is I need a moment of
I
peace.
need a moment of peace.
However many seconds of silence, and then I will go.
And then the bounce is I need a moment of peace. I need a moment of peace, and I will do whatever I mean to do. And then I will go do whatever I mean to do. And then I will go to whenever I mean to. So this is especially useful for handling this series of eventual values. Not only as a UI specialist, which is something that you are going to do a lot, but also as a backend developer, right? Especially if you're going to consume raw data, streams of data.
Do whatever I meant to do. So here we can put the delay 2 seconds. Let's just get rid of that. Let's just say throttle time. And so now I can go to town on this. And really, about every 2 seconds, you'll see another one appear, even though I am out of control. Right? And then we've got the bounce time for 2 seconds.
The bounce time, which is
don't do anything. I can keep going. I can keep clicking. I can go out of control here. trigger whatever it is, that thing I never want macOS to do. I don't need the dictionary word in my browser. But I can keep clicking on it, and until I stop for 2 seconds, then we'll see it actually happen. Again, autocomplete is a great use case for this, right? I don't want to hit the API until.
Exactly. So for example, in the case of Debounce. So Debounce is useful for autocomplete. Yeah, for autocomplete feature, man.
They've chilled out for a moment, I know they're done, right? Anything that might be potentially expensive.
So if you go with this, you say, hey, instead of using a delay, we can say it's throttle for 2 seconds, right? So I'm gonna let pass all of that. I don't know if I'm running this. Yes. I'm gonna let it pass through all of this. So I'm busy. Wait a moment. Okay. But it's gonna handle that. I'm busy. Wait a moment. Oh, I think I'm using is exactly throttle. We're using throttle. Yeah, throttle here. Throttle. That's interesting. So I'm busy. We only throttle to the thousands.
It's now for however long, right?
Oh, that makes a lot of sense because it's throttle time. Exactly. I am now is here with throttle is letting one of this pass through and the duration, you know, and letting is just only one this, but it's throttle time. This is the operator. Throttle time makes a lot of sense. Okay, so this replicate is this. It's like, and I'm busy. Wait for it. Like I'm gonna do this. I'm busy. Wait for it before it handles it. Okay, but I'm busy. Wait a minute. So I'm busy. Wait a minute. But as you can see, it's going to now handle that, right? Whereas with Debounce, let me actually take a screenshot here. Okay. Whereas with Debounce, instead of we say Debounce time. So this is useful, especially if you want to reduce the amount of API that your app needs to do. All right. The amount of API requests that your app needs to do. Useful for exactly notifications like that. Oh, we didn't update that. Debounce. There you got it. The bounce time.
Until the student can appear, which is that thing that like most either ignore things are dependent. That's about which is.
So this is the bounce time. Exactly, now it's going to work as expected. Give me a moment of peace before I'm doing the things to do. Exactly. So give me a moment of peace before I'm doing the thing that I need to do. This is debounce. And throw is wait before doing this stuff. So I'm busy, wait a minute. So I'm busy, wait a minute. And then I can process that. So it's quite interesting here. So now the bounce says, give me a moment of peace before, give me a moment of peace, and then I will do, give me a moment of peace, and then I will do, and then I will go to do whatever I'm into. So give me a moment of peace, and then I will do, and then I will do whatever, and then I will go, and then I will do whatever I'm into. Right? This is the bounce. So the terms of the bounce is quite clear. It's not that hard. You know, it's quite clear. This is throttle. Exactly. And this is the bounce. Right? This is now the bounce. And then you got now throttle. Throttle. I don't know how to write throttle, right? Throttle and the bounce. Throttle. So throttle is a mechanism for, it's a regulator, okay. Yeah, the bounce. Throttle says, wait, I'm busy, wait a minute. So I'm busy, wait a minute. Exactly. So I'm busy, wait a minute. And here we paste now this. This is for throttle. So the bounce and throw. So the bounce is wait. So the bounce says, give me a piece. Okay. So give me a moment of peace, and then I'll do whatever I'm meant to. And throw says, yeah, give me a moment of peace. You can click here. Give me a moment of peace, and then I'll do whatever I'm meant to. And throw is, I'm busy, wait a moment, but I'm going to process that. Okay.
Basically, until another observable emits a value, time it at that point and get a sense for it. And then we've also got just throttle and debounce. And those work like skip until and take until, which is basically until another observable emits a value, either ignore things until this other observable emits a value, or do a thing and then stop listening until something emits a value, right? So if you have two things that maybe are dependent, you can then tie them together with just throttle and debounce. Effectively, we'll look how to write throttle time and debounce time in a second, But we also have that panic button on the screen, which is just, I couldn't come up with a better name for a button, to be honest with you. So we'll say panic, clicks, is from event.
It's from event
Panic
of
button.
this panic button.
Button, click.
On the
And
left.
so we've got that, and now we could theoretically debounce
say debounce
based on
this
panic
another
clicks.
observable
Just so
here.
JavaScript doesn't get angry with me. Let's do it in order.
Yeah.
What happens to Observable if you don't subscribe to it?
Nothing
Nothing happens to Observable. If Observable
Exactly.
exists and no one's around to subscribe to it, then it doesn't really matter. So we don't actually care what this one does in this case. And again, like we'll find ways to kind of batch them and automatically
So we
subscribe and
just
unsubscribe in a little bit, but we do know
creating
that we need to
observables,
subscribe to it.
and then we need
Otherwise
to
we'll never
subscribe
know
that.
This one actually returns the observable that you need in this case. So here's the observable. It needs a factory function in this case, right? Because it's not. Actually, I think that'll work actually, because this will basically do what I just threatened to, which is this function will return an observable that Debounce will subscribe to. Keep hitting it until they hit the panic button. So this function creates an instance. It's a factory function. Create an instance of a panic.
So this instance creates an instance of the panic observable.
I click observable. Once that emits, it will then go ahead and let it through. Throttle will do the opposite.
Throttle will be the opposite, which is what?
What I just threatened to, which is this function will return an observable that Debounce will subscribe to.
It will be debounce.
Keep hitting it until they hit the panic button. So this function creates an instance. It's a factory function. Create an instance of a panic click observable. Once that emits, it will then go ahead and let it through. Throttle will do the opposite.
Throttle will say, hey, let's things pass through to do something. Or in other words, I'm busy, wait a moment.
Where we can create a notification, but nothing happens until we hit the button again, and then we're allowed to have another one through. Right, so different ways to basically start and stop different events from flowing through. I would argue that throttle time and debounce time are probably more common, but if you find yourself like, okay, like once they started dragging, ignore stuff until a drop event happens, so on and so forth. You have the ability to have control over different events that fire and begin to orchestrate them and coordinate them.
At some point, being smooth or like very responsive to prediction becomes very resource intensive. So not setting a 300 millisecond, but waiting for events to end. Do you have a sense or a comment on how RxJS handles that if we want to wait or want to wait for the end of the session? How much resource, how much load is going to get placed? I
mean, you are playing with memory in this case. The more you're keeping track of, the more memory you're managing, right? There are ways to basically coordinate switching between two observables that exist. So later we'll look at exhaust map. So like exhaust map says like, cool, until I'm done with what I'm doing, ignore everything, right? But it will kind of orchestrate that and coordinate it for you. Switch map will say, forget what I was doing, I want to go do this new thing. And some of the, there are optimizations under the hood. So for instance, you're using from fetch and you use switch map and it stops caring about the results of that fetch, it will actually cancel the fetch request, right? And use the abort controller on the fetch API. So you can, kind of do stuff. But yeah, the more you are keeping track of, the more memory you are going to use. And so it's, everything is a set of trade-offs. It depends on what you're optimizing for. If it is optimizing for DDoS in your own backend, then a little bit of memory usage probably isn't the end of the world. However, if you're already playing on the edge, then you might choose to handle it differently. So we're going to talk a little bit about, we've dealt with like individual streams. We've even had some observables that will listen to others. But now we're going to talk about some strategies for kind of combining and merging multiple observables together. A really great example, if you think about that counter that we had before, we had the interval eventually listen to the start and the stop button, but those are kind of just two sides of the same coin, right? It'd be great if we could simply like create a stream on whether or not they've hit, we should be going or not. We have a version of that here. This is kind of a quick tool that I built. We'll see how to build like a simplified version in a little bit, but a quick tool that I built to kind of visualize a bunch of different observables together, right? And as we kind of merge them. But we're going to build a little bit together before we use it. Because right now these buttons don't do anything. So I'm going to kind of get at least the start and the pause working. And this will be a little bit similar to what we eventually we've seen before and where we'll take it forward.
Merging timelines.
Okay, so I've got the start, and let's actually grab the pause button. And they are each individual ones. Now, what if I wanted to merge them together? And maybe start we want to be, yes, you should be running. Pause, no, you should not be running. That seems reasonable, right? So we could theoretically take each one, and we could say .pipe. Map to, we'll map this one to true. And we'll say .pipe.
It made that.
Map to, and we'll map that one to false. And now I just want one stream of either the true values or
true
the
values
false values.
or false values. Actually, now you have
let's make a
two
new
streams
observable.
of either true values and false values. So it is
And
running.
that's going to simply use a new kind of creator. We used of, from event. This one's called merge. You can take a lucky guess what it does.
It takes
will
two observables.
Merge two streams into one.
Into one.
So we'll start with the start and the pause, and we'll merge them together. And we'll even start with saying, and by default, even before they click a button, let's just start with false. So we'll give it effectively a default value even before anything gets emitted from either one of those events. Great. And we'll start with the simplest possible thing here. We'll say is running.
Which is running the subscribe.
And we'll subscribe to it.
Okay. I want to know is
All right. The really cool thing here is you'll notice that we didn't have to subscribe to start and pause individually, but we were able to kind of merge them together. And when we subscribe to the merged stream, we will effectively be subscribing to the two child streams in this case. So let's just verify that that does what we think it does. Starts out with false. It says true, false, true. Great. Everything kind of works. At this point,
it's merging
instead of
all
logging
of
into
this.
the console, I have this set status, which is going to manipulate the DOM a little bit.
Okay.
So now you can see it starts out as paused, it's running, it's paused, it's running, right? Because it's based on what is happening in that case. So set status is basically, we can look at it in the utilities, but it's like, if true, show running.
Show running. If
false,
false,
show pause.
show pause.
So we kind of get that functionality out of the box for free. Now, that's merge, and there's a bunch of different ways that we might want to deal with merging two timelines, right? So what we're going to kind of do is play around with visualizing this. You'll see, you can't really see them yet, but there are 3 columns. And so we're going to take 2 different streams. We're going to look at some of the different strategies for merging them. The first will be what we'll call our first observable. The middle stream will be our second observable. And the third one will be our combined observable in this case. So what happens when we merge them in 2 different formats? We saw merge, but you can imagine all it does is it takes anytime any of the children emit an event, merge shoots that event on through. It's just combining 2 in the simplest, most direct fashion. I have this little helper function called bootstrap, and all that does is in utilities I've got a little bit more complicated observable. We'll see simpler versions of it later. That kind of just powers this whole exercise so we can visualize it. So the only thing that I have to do at some point is pass the 3 observables to this bootstrap function. It is not an RxJS thing. It is simply to get this thing up and running. So one of the things I want to do is just create 3 different streams. I do have this helper called label with. Label with is simply, it's annotating it with the right class name and the label. It's just basically doing it under so I can visualize things. It's not part of RxJS. I'm just mapping the value to, it's effectively a version of map2, but I also do the other things I need to make them look the correct colors. So if we flip over and clear this out, you can see I can start it. It runs 1, 2, 3, and then it finishes, right? So these are 3 independent streams. But combined is capable of bigger and better things. Combined should be the merge of these 2, right? So if we go ahead and we can kind of replace this here, we can say, okay, merge first
and
the second observable. So now combined is any event that comes through first, any event that comes through second is now combined, merged into 1 observable stream. So let's take a look at what we have. We have 3 streams going still. We've got first, which is the first one independent. Second, which is the second one independent. And then combined, which is both the first and the second one kind of
combination between the first and the second.
It should look basically like, the timers are slightly or similar, so they could come in a little bit interweaved. But basically, anytime either one of them emits, we should see it on the combined stream as well. Let's go take a look at that.
So the way thing is that we're going to see that is exactly. But only the first and the second
That
one.
we actually only need to call this one merge. I don't need to label it. Awesome. So you can see
Exactly.
they're color-coded correctly. They're all kind of coming into one combined stream in this case. And that might be what you want, right? A lot of times that is what you want. Like take these two things for our start and our stop button. We don't, like whenever one of them happens, pass it through to this combined stream. And a lot of times that will solve for the issue that you want. But there are other strategies, and we'll actually see some of these play out later, where you might want to have a little bit more of an opinion on
Or control.
right?
Mhm.
So you might want to say,
The order
hey,
of this.
I have these 2 streams, 3 streams, 10 streams, what have you, right? I have these streams. What I want to do is play through all of the first one, then play through the subsequent ones, right? And merge is not going to do that for you. Merge is first come, first serve, right? Whichever one emits is into the merge stream.
Okay.
Concat is going to go ahead and say like, cool, I want to run through the first one to completion. It's one stream. We'll do everything in the first stream. We'll do everything in the
So
second.
this is okay. So this merge is gonna take whatever string comes first, whoever string is sending, whoever string sends first, I'm gonna merge that, right? That might be something that you want to do, all right? If you don't care about the order, you just only care that, hey, I want you to now send this data.
Stream, so on and so forth, right? And you can do some interesting coordination with this, which is like, okay, like I want to do everything I need to show the loading page, right? Then I want to do everything I need. Whatever's involved there, I don't care. I want to play through the first scene. I want to do everything for the second scene, everything for the third scene. So we can go ahead and we can just swap this one out for concat. And we'll see that this behaves slightly differently. Now what I want you to notice is it doesn't matter when things get emitted from the second one. The combined stream won't even subscribe to it until it is done with the first one. You notice is it doesn't matter when things get emitted from the second one. The combined stream won't even subscribe to it until it is done with the first one.
Okay, but this is what they
they're going-
combine.
We don't get anything from the second stream until we've finished everything on the first stream, and then we begin listening to the second one, right? So merge these 2 streams, but work on them in order. Take the
But
first
work on
thing,
them in
finish it
order,
to completion,
exactly.
move to the second
for
thing, finish it to
coordination.
completion, so on
Exactly
and so
for
forth.
concat.
We've got another one called race. Anyone have a lucky guess what race does?
Whichever
First
finishes
one wins.
first.
Yep.
Yeah.
Right. Well, emits first in this case,
Exactly.
right? Like, so it's kind of like
Whoever
promise
emits
dot race.
first?
Promise dot race is like, listen, here's a bunch of promises. Whichever one of you resolves, let's go for it. Race is also similar, where you can be like, cool, here's a whole bunch of observables. Start with whatever one emits first. I don't care. So we'll swap that one out. And
To
let's
race.
say that first we're going to have it take 1,500 milliseconds. So if you can kind of see that the second one started first, and like the first one could go on forever. It doesn't care. Like the combined one only talks to winners, right? And it doesn't talk to anyone who comes in second place. And so it's a way to say like, okay, I have these 2 things going on, whichever one emits first. One of
Exactly,
right,
whichever
started
one
first,
emits first,
take 1,500.
which is the
milliseconds.
second. Exactly. So we're gonna take the second
So-
values only.
If you can kind of see that the second one started first, and like the first one could go on forever. It doesn't care. Like the combined one only talks to winners, right? And it doesn't talk to anyone who comes in second place. And so it's a
So it
way to
only
say like,
talks to
okay,
winners.
I have these 2 things going on, whichever one emits first. One of the things that we'll see later is you want to show a loading indicator, but maybe only after a certain amount of time, right? So hey, 2 seconds for loading indicator. If the data comes back before 2 seconds, the data wins. If the data has not come back after 2 seconds, well then the loading indicator wins, right? And show the loading indicator, right? You still need to do something with the data, and we'll figure out how to manage that all in a little bit. And it could be like, cool, show the loading indicator, then get the data, then take everything down, right? So this ability to merge things, but also sequence them and figure out the order of operations between them becomes incredibly powerful. Another one that you'll see sometimes is just called fork join. It's not the most glamorous name in the world. And you can kind of see that's also deprecated in this case, but it is real common. So it passed the bar in this case. So what this one does is it waits for them all to finish and gives you an array of the last value of each. So nothing in the combined
Exactly.
stream.
So wait for all of this to finish, and then
They finish, I get the 2 values.
the 2
last
values
of
here.
each of them.
4
Right.
conjoint.
Cool. So we have different ways to mix and match these. Now, where this becomes interesting is when we kind of put them inside of other observables. We can kind of get a little bit more powerful with that as well.
But it says merging timelines here.
So we're going to talk a little bit about
Okay.
what's called kind of higher order observables.
Okay.
Higher order observables are, if you think about higher order components in React or name
Higher
your
order
framework of
functions.
choice, it is simply a component that renders another component. And in most programming, everything is easy until you get to the point where you are, when you like mapping over an array, fine, I can do that, anyone can do that, iterating over an array. What happens if that array contains an array? Oh, well now you've got to recursively go into that array, do everything in that array, so on and so forth, right? And so you can either use recursion, and then, for instance, JavaScript these days, right, has a built-in like flat map. The idea of like take this multi-dimensional array and just make it one regular array of all the values. That is also super useful in terms of working with observables, right? Okay, they have clicked, great, but that click, like maybe what you want to map it into a promise. Well, a promise, in this case, will also become an observable. So now you've got an observable floating down your observable stream, right? Well, really, you don't want the observable in that case, you want the value. Mark.
Some of these operators be used to implement an undo operation in case an optimistic UI update should roll back.
I mean, you could, right? Like, if you think about scan, you can take care of all of the state, right? There's also, you have the ability to kind of replay in some cases. I think with scan is probably the best way to do it, right? Because for a lot of these, we'll see the ability to like switch between pieces, but keeping track of that state and taking the different events that kind of go through and be able to manage all of that will let you kind of adjust that as you go along. So yeah. With most things, everything is easy until you have things that appear in other things. So for instance, this would be problematic. Remember when we slammed on when we had that original delay in the notification, we slammed on a bunch of times, and yeah, we waited 2 seconds, and then we got all of them, right? If you wanted to theoretically have a observable that then will use of to then delay it a certain number of milliseconds, well, now you have an observable in your observable. And so you know what you'll get is when you subscribe to example, you're going to get an observable, because that's what you return from your map, right? It's not what you wanted. Sometimes we don't get what we want. We get what JavaScript tells us we get, and we like it. So that's what we'll get in this case. And like a more common example is the button got clicked, or here was a string, or here was an array of things I wanted to use from fetch to get observables. Again, now I have a stream of observables that have a string. What I really want to do, if I can take 2 observables from the top level and merge them together, I should be able to take observables in my observables and flatten them into the main observable, like the sacred timeline, if you will, and merge my timelines into the main timeline in this case. And if you're thinking I should be able to do that, good news, you're thinking correctly. Of a stream of observables that have a stream. What I really want to do, if I can take 2 observables from the top level and merge them together, I should be able to take observables in my observables and flatten them into the main observable, like the sacred timeline, if you will, and merge my timelines into the main timeline in this case. And if you're thinking I should be able to do that, good news, you're thinking correctly. So one strategy for doing this, there's an operator called merge all. So merge all will basically take all of the kind of child observables in your stream and merge them together, just like when we merged the first and the second observables before, right? Now, this is common enough that there's also a fun helper called merge map. You want to take a lucky guess what that does?
Merges maps together?
Yeah, it's like flat map, right? It maps, and then it merges them all together. So a lot of times you will see that happen way more frequently than you will map and then merge. You'll usually just merge map and save yourself a whole, I guess, 9 characters or 10 characters of code. I guess the comma, so 11 characters of code. You can merge map, and you can do it all in one pass. And a lot of the rules that we saw before apply as well for concat. So concat will do the same thing. It will do what concat did previously. You'll map over all these items. They'll become nested observables. Play through the first one. Then play through the second one. Then play through the third one, right? Or so on and so forth. Right?
So similar to merge all and merge map, but it's placed through the observables in order. Hey, runs through the first one, observables, and then once that is done, the second one.
Right, it all depends, like the unique problem that you're trying to solve. If you don't have opinions, merge is your best choice. You're like, whatever. someone emitted, I want to deal with that value. But there are times where you want to coordinate and orchestrate the different asynchronous events, and that's where concat and 2 other fun ones are going to show up.
So for example?
So the more useful ones, even merge map, super useful. Concat map, sometimes useful, like when you need it in particular. Switch map and exhaust map are like cousins of Debounce and Throttle, right? And they kind of, again, work they work the opposite of each other. Switch map says, drop whatever you're doing, something else has emitted. I don't even care what I was doing previously. Forget it. I don't want to know anymore, right? I want to do the new thing. Exhaust map is a little more stressed out. It's like, I'm very busy. I'm doing this thing. I'm not doing other things. So I'm done with this thing. And then, if anything else is there to be done, I will go do it. The interesting part is, like very similar to Debounce and Throttle, switch map will simply cancel, stop, no more. It'll move on to the new hotness every time. Exhaust map will just ignore things until it's done, right? When it's done, then if something else wants to emit, it'll switch over to that one, but it will finish what it did, what it's done previously. Now, we've talked a little bit about autocomplete along the way here. So for instance, like, cool, maybe they stopped typing for 300 milliseconds. Our debounce time has fired. We're ready to make another request. I don't care that you're halfway through an API request that's taking too long. We're done. They're no longer searching for that. I don't want to know when it comes back. I'm uninterested, right? We have new things we're searching for, and when that request comes back, whether it's before or after the other one, right? If you have like a slow internet connection, you're like, the first request might come back after the second one. You don't want to update the UI for the thing that you're done searching for. You want to update the UI for the thing they most recently searched for. Exhaust map will be like, we're loading things right now. I know they're rage clicking that button. We're loading things right now. We're doing it, right? This is maybe for data that's not going to change too much. You don't need to fire off a bunch of different requests. Like this request will get them the data they want. Just don't fire off new requests until this comes back. And then if they want to search again, fine, right? This could be a field where it's like, we are loading the previous thing. Cool. There's just a few more that we won't play with too much, but I just want to like make you aware of their existence. Remember we saw fork join before? It gave you the last value of all the observables. Combine latest all will simply, as long as all of them have emitted, it'll wait until each and every one of them emits. Once they have all emitted, you'll get an array of all the values.
Similar a los cubitos de letras cuando
So
uno está en
there's still one you're
preescolar.
waiting on, you
Similar
don't
to
get any.
those
But once
letter
everyone
cubes
has done something,
when you're in
you'll get an array of
preescolar.
all the things
It's
that
like you are
happen.
combining,
If you are
you can
impatient
think of
and
this
want
as a
ASAP,
string,
you can use a start
all of
with
these
to
cubes
kind of kick off
of letters
each one
as
of them,
strings,
and you'll get an
and then
array
you want
each
to
and every
merge
time
each one
any
of them
them
as it is, right?
So this could be
So
useful
merge,
if you're building a UI,
whoever
like,
comes first.
hey, I'm making a pixel painter, right? I want to know where their mouse is. I want to know what color, right? These are all things that can change, right? Give me the latest of all of these things depending on what we're doing, right? And then combine latest with is just a way to kind of, I want to rely on this other observable. Get me the last one of that every time. So the question is, if you use exhaust map and things happen while you're doing the first thing, are those things backed up into a queue? They're completely ignored. They're dropped, right? We're busy. We're not doing those things afterwards. They could have rage clicked to their heart's content. We're not dealing with it. We're not doing it. We're finishing what we did in this case, and we'll go ahead, and when we're done, we'll do the next thing, right? Like if an autosave is in progress, you might want to let that autosave go through. Or maybe you want to switch it to the new one. A lot of this will depend on the exact type of interaction you're trying to develop, but the idea is that you have these options. You have the option to kind of finish what you started. You have the option to drop what you're doing and do the new thing. Or merge, hey, I don't care. Like, things happen. Like, they can start and stop that timer. I'm unconcerned. I don't really care in this case. So let's go through and let's play with an example. So I've got this area for mapping exercises. And let's go play around.
That'll be all for this video. Take care. Bye-bye.